we're going to cover section 2.6, other types of equations, looking at polynomial equations and how you would solve them using factoring, and solving absolute value equations. First, you need to be able to recognize a polynomial. You've already seen quadratic equations, which are basically a polynomial equation of degree 2. Now you'll be able to have degrees that are higher than 2, but they're always still going to be integers. This slide is going to be saved for you to do with your instructor. However, if you would like to try now, you can try this in the PowerPoint and remove the box to check your answers. So as a review, remember that if you have something in factored form, that what you can do, if you know that this has to multiply to 0, one of those factors must be 0. So we have 3 is equal to 0, that comes from this 3, x is equal to 0, 2x minus 5 is equal to 0, or x plus 1 is equal to 0. Of course, you know how to solve each of those equations. 3 is equal to 0 is a ridiculous statement, so that would, of course, not be a solution. So we have, for our solution, 0, 5 halves, and -1. Notice how we write these in the order from smallest to largest. So this is the process we're going to use to solve polynomial equations. We're going to first set it equal to 0 and factor one side. Then we're going to set each resulting equation, each factor equal to 0 and solve the resulting equation. Of course, you can also check. So looking at these examples, we're going to look at these problems here. You'll notice that the first one has already been factored. So we can start off by setting each factor equal to 0. We have x is equal to 0, which is already done. We have 3x minus 1 is equal to 0, which if we add 1 and divide by 3, we get x equals 1/3. And finally, we have x squared plus 1 is equal to 0. Now this is not linear, this is quadratic, and we have the variable isolated within the part that's squared, so we can use our square root principle by isolating the squared part and then taking plus or minus the square root. Of course, then we're going to get to imaginary numbers because the square root of -1 is, of course, I, an imaginary number. So we really only have two real solutions. We have x is equal to 0 or x is equal to 1/3. For problem number 2, this one we included specifically because it kind of looks factored, right? But it is not at all factored because we have something besides multiplication between our terms. So the first thing we need to do is actually undo the partial factoring that's gone on here. We're going to distribute. We've got x squared times x, which gives us x cubed, x squared times 3, which gives us plus 3x squared. Then we're going to distribute the -25, so we have minus 25x, and then we have minus 50. Now we know that we have to set it equal to 0 to factor, so I'm going to go ahead and subtract that 25 from the right-hand side to the left-hand side at the same time. So now what we have is x cubed plus 3x squared minus 25x minus 75 equals 0. Now obviously it's definitely not factored because of all the plus and minus in between. So when it's in this form, when we have 4 terms, remember to factor, you either need to group 1 and 3, 3 and 1, or 2 and 2. Well, 2 and 2 is going to be the most common way we're going to be grouping our terms. Notice I'm not using parentheses because had I put parentheses around there, it might kind of look like it was factored already. It would look like multiplication. So we first pull out the greatest common factor from these first 2 terms. X squared is the greatest common factor. X squared into x cubed leaves us with x to the first. We divide x squared into 3x squared. We are left with a 3. If you want, you can check that by multiplying it back out. Next, we're going to take out the greatest common factor from the last 2 terms. And of course, 25 goes into both, and we have to take out that negative leading coefficient, which is -25. And I'm going to make a mistake on purpose. I want you guys to see what mistake I've made. Okay. First of all, I know that if my polynomial part here does not match exactly, I cannot go on to my next step. Secondly, if I were to check this distribution, I'd have minus 25x, which is what I would expect, but then I have negative 25 times negative 3 would give me positive 75. So I need to make sure that I check carefully and have all the right signs. A little sign error can make a big mistake. So now we have two terms, this x squared plus times x minus, let's try that again. This x squared times x plus 3 is the first term, separated by subtraction, 25 times x plus 3. So I'm going to look at each of these terms, and what they have in common is the x plus 3. So I'm going to take that out as the greatest common factor polynomial. When I divide it out of the first term, if I divide out that x plus 3, I have x squared, right? So I still have x plus 3 times x squared there, right? Minus 25 when I divide the x plus 3 out of the second term. So again, you can check this. We have x plus 3 times x squared, which is what we have here in the left term, and we have x plus 3 times negative 25, which is what we have here on the right. Now you have a choice. You can set each factor equal to 0 as is, or if you know how to continue to factor, you can. So here we have x plus 3 times x minus 5 times x plus 5 equals 0. Okay. Setting this first term equal to 0, we get x is equal to negative 3. Setting the next one equal to 0, we get x is equal to 5. And setting the last one equal to 0, we get x is equal to negative 5, which gives us three solutions, negative 5, negative 3, and 5. Let's look at example number 3. It's a little tight on space, so I'm going to draw a line right here so we can separate these problems. All right, so in number 3, we have 2x to the 5th minus 14x cubed equals 0. Okay. We only have two terms here, but you can't just start isolating things. We've got to first see if we can factor anything. As a matter of fact, 2 goes into each of these terms, and also x cubed goes into each term. When we divide 2x to the 5th by 2x cubed, we have x squared. When we divide 14 by 2, we have 7, and the x cubed divides out altogether, and there we have our factored form. So now, of course, we could write 2 is equal to 0, but we know that doesn't make any sense. We have x cubed is equal to 0, and we have x squared minus 7 is equal to 0. Okay. For x cubed is equal to 0, notice that really means x is equal to 0 3 times. We'd have that 0 3 times, and the 0 would be x is equal to 0. Okay. For the next one, we once again have quadratic form with the variable parts isolated squared. So I'm going to isolate that and use my square root method. And I have three solutions here. My solutions are 0, oops, not in the right order. Where's my eraser? Can't find it right now, so I'm just going to write this again. We have negative square root of 7, 0, and positive square root of 7. Found my eraser just to make it pretty. There we go. So let's go on to the next slide. Okay. These are the ones we just did. All right. So the next thing we're going to look at is absolute value equations. Okay. So remember that when we take the absolute value of a number, let's say the absolute value of negative 5, that's going to be equal to 5. But also the absolute value of 5 is equal to 5. So if I tell you that the absolute value of x is equal to 5, that means that either x could have been 5 or x could have been negative 5, and we would get the same true statement. Okay. So if you have an absolute value equation where you have the absolute value is equal to a constant, and that constant is greater than 0, then we're going to set up two cases for our two solutions, and this is going to be the most common one that we have. Of course, if the number over here had been equal to 0, if we had positive 0 or negative 0, it's still 0 because 0 has no sign. We'd only get one solution. And if a statement was something like the absolute value of x is equal to -5, no matter what x is, when you take the absolute value, it cannot be that thing. So we would have no solution if the constant after you've isolated the absolute value is negative. Because of that, you should always check your solution, just in case. Okay. So in this problem, we have the absolute value of 2x minus 1 is equal to -3. We already know that when you take the absolute value of something, it has to render you a positive number or 0. So this one would have no solution. That was easy, right? Okay. On this next one, it looks like we have maybe no solution again. However, notice that we have not isolated this absolute value. It's a very important first step is to isolate the absolute value to see what you really have. Because when we isolate that by adding 7 to each side, we can see that we have 2x minus 1 is equal to 4. Okay, so now we have that number. So what's inside that absolute value? Could have been positive 4, or it could have been -4. We have two possibilities. We're going to now solve each of these linear equations. Here I'm going to add 1, so I have 2x is equal to 5. And then I'm going to divide by 2. I have x is 5/2. Here I'm going to add 1 as well, so I have 2x is equal to, notice it's not -5, right? Because we started off with -4 plus 1 is now -3. And then I'm going to divide by 2, and I have -3/2. So notice I can't just put positive and negative some number there. I have to do each case separately. And my solution is -3/2 would work, and 5/2 would also work. I'll leave the check to you, but I'm pretty sure those are correct and that they both work. Okay. On this next one, remember what the first step is. I hope you're saying it to yourself. The first step is always to isolate that absolute value. So we're going to start off by subtracting 5 from each side, and this time we get absolute value of 2x minus 1 is equal to 0. So in this case, 0 is 0. It has no positive sign or negative sign. We're just going to solve 2x minus 1 equals 0, which gives us x is equal to 1/2. And I will again leave the check to you. So as a review, you first have to be able to recognize a polynomial equation. And basically, it's going to be something that has powers that are positive integers. Notice that if we have radicals in there or irrational numbers, as long as the variable part is not being raised to something weird like an integer or rational or irrational number or a negative number, then you're okay. So to solve that polynomial equation by factoring, remember what your very first step is. The very first step is you have to set it equal to 0. Then you can factor. Factor means you have things that are multiplied, and then you set each factor equal to 0 and solve the resulting equation. Finally, how you solve an absolute value equation. Once again, your first step is to, ooh, what happened here? I'm not sure what happened, but we're just going to talk our way through it. So to solve an absolute value equation, the very first step is to isolate that absolute value, set it equal to some constant. Then you're going to decide what to do, but most of the time for absolute value, you're going to have two different equations. You're going to set what's inside equal to that constant, and what's inside equal to the opposite value of whatever that right-hand side is. Thank you very much. That is the end.